In this video, we're going to discuss CRA models for multiplying a fraction by a whole number. So the example, we have two examples we're going to look at. This first one is going to be 3 times 1/4. So it's called multiplying a fraction by a whole number because we're starting, again, thinking of our equal group schema. 1/4 is the size of each group. So we're starting with this size of 1/4, and we're going to multiply this fraction by the whole number. So we're going to take that group size of 1/4 and take 3 iterations of this. Okay, so this is called iterating. So this first example is we're using a unit fraction where our numerator is 1. We have a different example where we'll look at a non-unit fraction. But so for our length model, this is a concrete length model that we have here. So if our group size is 1/4, right, this is one of the 4 equally sized parts that would need to be created to create this one whole. So if we have 3 groups of this 1/4, we're going to iterate. We're going to kind of add on repeatedly. So that's 1/4, 2/4, and then 3/4. So we can see that our total length there is 3/4. Right? We have three objects, and each object has a size of 1/4, or we can think of the name of each object is a fourth, so we have 3/4. And then same type of thinking for our area model down here. So we have 1/4, then we have a second fourth, and we have a third fourth. So we have 3 groups with the size of 1/4 for a total of 3/4. Okay, so that's a concrete model. Look at some representational models. So for the representational, and we might do these just to show the different groups. We might use different colors. That might be something that's helpful. So for a number line, we can just show this as jumps, or we can draw bars in there, but I'm just going to do it as jumps. Right, so that's one group of 1/4. And we have a second group with the size of 1/4. And then finally a third group with a size of 1/4. So our total length of all of those jumps then is length of 3/4. And then we can kind of do the same thing on our representational area model. So just shade in one with black, one with red, and then one with blue. So there we can see we have 3 distinct groups that each have a size of 1/4. And we can see that that total area is taking up 3/4 of the area of that circle. Okay. And then our abstract model at this point would just be this equation here. So 3 times 1/4 equals 3/4. So we're not really using the standard algorithm yet. We're multiplying numerators and denominators. We'll get to that one later. So this would kind of be the abstract model. Then we'll look at one more example where we don't have a unit fraction, right? So we just don't have 1 as the numerator. Okay, so I'll show a length model. So again, we have 3 groups that have a size of 2/12. So each of these black pieces, right, it would take 12 of these to make up the length of that whole. So this is one group that has a length or a size of 2/12. A second group, and then a third group. Okay, so each group that we were adding on to this length has that same size of 2/12. Okay, 2 pieces that each have a name of a 12th or a size of a 12th. So then we can see that our total length here is, right, we have 6 objects, right? And their size or their name is a 12th, so there we have 6/12. And then for the area model, it'll be pretty similar, right? So that's our whole object. So we have one group of 2/12, second group of 2/12, and then a third group of 2/12. Okay, so we can see that we have 6 total pieces there. I'll split them up just a touch so you can see the break lines in the video. Right, so we have 6 total pieces there. Each piece is called a 12th, so we have 6/12. And then representational model will be pretty similar, but obviously we're just moving in, we're shading or filling in bigger units, or more than one unit at a time, since we're doing 3 groups of 2/12. So this first jump on our number line length model, I didn't add all the tick mark labels in here, so made it cluttered, but so each of these, right, that's 3/12, 6/12, 9/12, each of these would be 1/12, 2/12, 3/12, 4/12, and so on. Okay, so that first jump is of 2/12, then another jump of 2/12, and then a third jump of 2/12. So you can see our total length there is going to be 6/12. And then kind of similarly on our area model, shade in 2/12 with one color, another 2/12 with a different color, and then another set of 2/12 for the last color. So we have 3 groups with the size of 2/12, and that again has a total area then of 6/12. And then that abstract model, again, we're not necessarily using the standard algorithm yet. We're just creating the 3 groups of 2/12 to see that we have a total group size of 6/12. So it'll just be this equation.